All right, and welcome to Accurately Graphing Radical Functions. Now, this is a fairly difficult lesson for students. I'm only going to provide two examples because they do take a little bit of time to work out, but I really want you to kind of understand what I'm going for here. So, let's kind of say this. In order to accurately graph this, you need 3 points. Okay, so I'm going to write that kind of as a requirement. We need 3, and I'm even going to call these perfect points. Or we could say another way of saying it is 3 integer points. Now, how in the world are we going to do that when we have a radical? Because, like, for example, if you took the square root of 2, you plug in the wrong x value, you get the square root of 2, you would get something like 1.71, I think. Okay, so what are we going to do here? Well, we always want to take whatever is inside the square root, and we want to set that actually equal to a perfect square. So this means that we need to know what are my perfect squares. Well, my perfect squares, let's see, what are some easy ones? All right, my perfect squares. There's 0, because the square root of 0 is 0. There's 1, because the square root of 1 is 1. And guess what? The next easy one is 4, because the square root of 4 is 2. So I guess the best way that I want you to really think of it, if you just want a very nice, easy general rule, is you should always endeavor to set whatever inside the square root equal to 0, 1, and 4. Okay, so let me just kind of show you. So I'll say, okay, well, you know what? X plus 3 is equal to 0. X plus 3 is equal to 1, and x plus 3 is equal to 4. Okay, so if I subtract 3 there and subtract 3 there, well, I see that x is equal to negative 3. If I subtract 3 there and subtract 3 there, I see that x is equal to negative 2. And if I subtract 3 there and subtract 3 there, well, I see x is equal to positive 1. These are the 3 x values that we actually want to take to plug into our function to get our perfect y value outputs. Okay, so let me just kind of clear this off, write this over off to the side, and let's just kind of say this. We're going to say, you know what, x is equal to negative 3, comma negative 2, and positive 1. And with that out of the way, we can actually just go ahead and start plugging in these things and finding our outputs. Okay, so let's go ahead and say this. I say, you know what, I have f parentheses is equal to the square root of x plus 3 minus 4, where my very first x value will be negative 3. Okay, and let's just work it out. So I say, okay, well, we have f of negative 3 is equal to the square root of negative 3 plus 3 is 0 minus 4. I know the square root of 0 is 0 minus 4. And now this gives me the final answer. 0 minus 4 is negative 4. So my y value is actually equal to negative 4, comma. All right, guys, I would encourage you to pause this, finish taking your notes. Let's move on to the next x value. And you know, a cool thing here, if you're using an eraser, or I don't really know if you would do this actually, but I can, for my screen for sure, I can just erase my inputs. Now, I'll go to my next input, negative 2. Okay, and let's just kind of start working through this. So now I have f of negative 2 is equal to the square root of negative 2 plus 3 is 1 minus 4. I know the square root of 1 is 1 minus 4. Guys, we're just doing simple arithmetic here. And now I know 1 minus 4 is negative 3. So my next y value is negative 3, comma. Pause the video, finish taking your notes, and let's try out our last input. Okay, I see that my last input is a positive 1, so this one, you know, jumped a little bit, changed, and now we have f of 1 is equal to the square root of 1 plus 3. Y'all know 1 plus 3 is 4, minus 4. I know the square root of 4 is 2 minus 4. And now we get our final answer, where f of 1 is equal to 2 minus 4 would be negative 2. Negative 2. And this actually winds up giving us 3 points. Y'all see here our very first point, negative 3, comma, negative 4. You see our second point, negative 2, comma, negative 3. And you see our third point, 1, comma, negative 2. So if I want to accurately graph this function, the square root of f of x is equal to the square root of x plus 3 minus 4, well, it's this easy. I go to the left 3, 1, 2, 3, 1, 2, 3, 4. There's my point, negative 3 comma negative 4. I have a point at negative 2 comma negative 3, and I have a point at 1 comma negative 2. And there you go. I have perfectly graphed that function. Alright guys, I want to go ahead and try one more example. Please pause this, finish taking your notes as needed. Okay, here's example 2. Graph g of x, which is equal to negative square root x minus 7 plus 3. Okay, well, even though there's a negative out in front, it really doesn't change anything. I know that I want to start by taking a look at that x minus 7. And I'm going to write it 3 times because we need to know 3 x values. And the next thing that I want to ask myself is like, well, what do I want to set each one of these to? Like, what are my perfect squares? Okay, so my perfect squares are 0, because we know the square root of 0 is 0. There's 1, because the square root of 1 is 1. There's 4, because the square root of 4 is 2. And there's also, we could continue on. There's 9. The square root of 9 is equal to 3. And we could even go as high as 16. The square root of 16 is 4. Okay, I don't have to set these equal to 0, 1, and 4. I could set this one equal to 0. I could set this one equal to 4. And if I wanted to, I could set this one equal to 9, right? I can set them equal to any perfect square if I want to get a perfect output. Okay, and let's see what all of these give me. I know that to get x by itself, I will simply add 7 to each side to get rid of that negative 7. And what do we get? We get x is equal to 0 plus 7 is 7, 4 plus 7 is equal to 11, and 9 plus 7 is equal to 16. And this might be a little trickier to graph, but these are my 3 x values that I am going to use. X is equal to 7, comma 11, comma 16. Now what do I want to do? I want to take these values and I want to plug them back in so that I can get my outputs. So I have g of x is equal to the negative square root of x minus 7 plus 3. And let's go ahead and tackle our very first input, which is 7. Positive 7. Okay, I see g of 7 is equal to negative square root of 7 minus 7 is 0 plus 3. We know that the square root of 0 is 0 plus 3. A negative 0 is still 0 plus 3. And 0 plus 3 is 3. And at the very end, I have my g of 7 is equal to 3. So I know that my very first output is 3. Finish taking the notes here, pause the video, but let's move on to our next input. Okay, next, let me go ahead and plug in 11. So now I have the square root of 11 minus 7. I know that that's 4 plus 3. I know that the square root of 4, I made a mistake here. I know that the square root of 4 is 2 plus 3. And now I have negative 2 plus 3, because remember I'm keeping that negative in front the whole time. Well, what's negative 2 plus 3? That's 1. So my next y value is going to be at 1. Alright? And let's go ahead and let's do our final input. I know that my final input is going to be 16, because that's what we chose. Oh, be helpful if I erase that. Okay, and let's start working down. I know that I have negative, here, my apologies guys, I wrote a sloppy negative there last time. I know that I have negative square root of 16 minus 7 is 9 plus 3. I know the square root of 9 is 3 plus 3, and I know that negative 3 plus 3 is 0. So my final my final output, my final y, is 0. That's a 1, by the way. Okay. And now we can go ahead and graph this. Let's see what this looks like. Oh, and by the way, if you want to see like what does it look like to write our points, well, we have 7, 3, we have 11, 1, and we have 16, 0. And so notice, oh, you know what? What I really want to do is I want to go ahead and put my y-axis way over here and really extend out my x-axis, because we have to go out 16 units. Let's count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And it looks like we have to go to at least a height of 3. 1, 2, 3. And we can see here that 7, 3 goes to the right 1, 2, 3, 4, 5, 6, 7, and up 3. And there is our very first point, our vertex. And here we can go to the right 11, so that's 7, 8, 9, 10, 11, and up 1. And lastly, we can go to the right 16 and stay on the x-axis because it's 16, 0. And there you go. Oh. Here. I did that really bad. Guys, once again, I'm writing with kind of a bad stylus. Y'all have my apology. Let's see if I hold it down. Maybe that'll help. Nope. Sorry, guys. This stylus is just sloppy. Alright, but it goes through those 3 points. And you can just kind of see, like, what is the graph looking like? It's just curving down. Alright, guys, I hope you get it. Alright, well, good luck on this, and I'll catch y'all in our next lesson.